Yes, Roji, I am audible
Good
to you.
evening, sir. Yes, sir. Good evening, sir.
Yes, good evening. Yes, today, have you completed the titration section?
No, sir. You told me you will talk for organic chemistry, no?
Yes, chemistry section. The last
Yes,
time
sir.
we have discussed in the topic in inorganic.
Inorganic.
Yes, okay, no problem. Yeah, let we start basic introduce yourself.
Sir, I am Rosie Patel. I am from Sundargarh, Odisha. I did my matriculation from Sri Aurobindo School, Sundargarh, with 91.16 percentage, and I completed my 12th with 72.5 percentage, and I did my bachelor's degree from Government Autonomous College Sundargarh, having 9.5 CGPA, and I have completed my master's from Sambalpur University having 87.5 percentage. Then after I have qualified some all India exams like GATE with rank 285 and CSIR NET exam with AIR 98. And now I am doing my PhD at NISER Bhubaneswar.
Yes, good.
Thank you, sir.
Yeah, next move on organic chemistry. Yes, what the basic application of organic chemistry?
Sir, organic chemistry have lots of application. Like it has some pharmaceutical application, medicinal applications. It is used in preparing cosmetics and all these things. Industrial applications,
Yes,
various type of applications are there.
yes. First basic is GOC, General Organic Chemistry. Yes, what is General Organic Chemistry?
Sir, in GOC we generally study aromaticity and the nature of nucleophile, electrophile, uh, different type of concepts like inductive effect, mesomeric effect, resonance effect, hyperconjugation effect. All these effects which are contribute towards organic chemistry we studied in the GOC.
Yes. Yes, first is resonance effect. What is resonance effect?
So resonance effect generally explain the stability of the complex. So, like in for benzene, we saw that three double bonds are there in the ring. But this is not the actual structure of the benzene. These double bonds are always in resonance conditions and contribute towards the stability of the benzenes. The bond of the benzenes are not purely single bond or not purely double bond. It is in between it. This can be explained by resonance effects.
Next is inductive effect. What is inductive effect?
Sir, inductive effect generally is a polarization effect. If any group or atom attached to the hydrocarbon chain, how it will create a positive charge or negative charge in the partial positive charge or negative charge in the carbon, it can be determined by inductive effect. It is a partial polarization effect. And it will decreases when the carbon chain length increases. It is two type, positive inductive effect, negative inductive effect, based on the group attached to the carbon chain.
Yes. Next is what is mesomeric effect?
Sir, mesomeric effect is also a kind of resonance effect when a group or something attached to the ring, for like example nitro group attached to the benzene ring, it will undergo resonance and pull the electrons towards itself and create a electron deficient center around in the benzene ring. And somehow sometimes measure is also plus m and minus m. When nitro group and when OH group is attacked, it oxygen donates its lone pair to the benzene ring and create negative centers around the benzene ring. This is the plus M effect of OH group.
Yes. Next is hyperconjugation.
The hyperconjugation effect is also explain the stability of the organic compounds. It is generally no bond resonance effect. It means here the uh, alkenes attached to the sp3 carbon containing hydrogen will so undergo resonance with this double bond and contribute towards its stability. More the hyperconjugative structure, more will be the stable the compound.
Yes. What the stability order of resonance effect, hyperconjugation, mesomeric?
Sir, first we prioritize the mesomeric effect, then hyperconjugation effect, then uh, inductive effect.
First one is
Sir, mesomeric or resonance effect.
yes. Second one,
Hyperconjugation effect, sir.
yes. Good. Next, first basic point is organic is reaction mechanism. What is reaction mechanism and how many type of reaction mechanism?
The reaction mechanism means how a organic reaction can be carried out or how much path this will follow to undergo reaction. This is studied under reaction mechanism. Under reaction mechanism, various type of reactions are there, like substitutions reaction, addition reaction, eliminations reactions are there.
Yes, addition, substitution, elimination, and rearrangement.
Yes, sir, rearrangement reaction.
First is addition reaction. What is addition? How many types of addition?
The additions reactions are also two types. One is electrophilic additions reaction and nucleophilic additions reaction. In electrophilic addition reaction, a species which is electron deficient attacks to the electron rich centers like alkene and uh, give addition product. In nucleophilic additions reaction, the species which is rich in electron or and containing negative charge will attack to the electron deficient center and give the addition product.
Yes, electrophilic and nucleophilic and free radical. Yes, no.
Yes, sir. Sorry, sir.
Next one is substitution reaction. How many type of substitution reactions?
The substitution reactions are also various type like SN1 reaction, SN2 reaction, SNI reaction. Different type of substitutions reactions are there. In SN1 reaction, it is a unimolecular nucleophilic substitutions reaction. Here, the nucleophile attack to the in SN1, the rate of the reaction depends on only the substrate concentration. Here, the reaction is proceed through a intermediate formation. But in case of SN2, it was bimolecular nucleophilic substitutions reactions. In this, the rate of the reaction depends on both the substrate and the nucleophile. Here, the reaction proceed by formation of transition state, and the reaction rate also depend upon the stability of the transition state. In case of SNI, it was nucleophilic substitution uh, inversion reactions. Here, generally OH or alcohol group shows reaction with thionyl chloride. Here, the retention in stereochemistry was observed in this type of substitutions reactions.
Yes, SN1, SN2, SNI, and SN1CB. Yes, what are the differences of these one?
That in SN1, as it was named SN1, that means here the rate of the reaction only depends on one factor, that is the substrate concentration. Here the reaction proceeds through intermediate formation, and the whole reaction depends upon the stability of the intermediate. If the intermediate is more stable, then the SN1 reaction is proceed more faster. But and here the product form will be racemic mixture, because here the attack of the nucleophile can be done from both sides of the intermediate, because in intermediate the intermediate was planar in nature, so here the nucleophile can attack from both the sides and form equal percentage of enantiomer, and the mixture was formed and racemic mixture. But in case of SN2 reactions, it is like bimolecular nucleophilic substitutions reaction. Here the rate depends on both substrate and nucleophile. So, and these reactions proceed through transition state formation. So whole the reaction rate was depends upon the transition state. If the transition state is stable, then the reaction will more faster. And here the product form was inversion product, and the nucleophile will attack from less bulkier side, or the steric effect plays major role in this reaction. And in SN1CB mechanism, here a formation of a conjugate base by the nucleophile. The nucleophile will abstract a ionizable proton first, then it form conjugate base, then after the leaving group will leave and form the substituted product.
Yes, good. Next is elimination reaction. How many
Yes, sir.
types of reaction?
Elimination reaction is also another type of reaction. Elimination reactions are generally required high amount of thermal energy. It is proceed in case of in presence of heat. Generally, these are mm, for elimination reaction. We need two bond breaking, so it's require high amount of thermal energy. So elimination reactions are two types. One is E1, E2, and E1CB, three types. E1CB mechanism.
Yes. E1, E2, and E1CB.
Yes, sir.
Next is rearrangement
In
reaction. Yes, carry on.
yes, sir. In E1, elimination reaction, a base generally first the leaving group will leave and then form carbocation or some intermediate, and then the base will abstract the ionizable proton, and more stable alkene will be the form. But in case of E2 reaction, simultaneous abstraction of proton and leaving group will leave at simultaneously, and the leaving group and the protons would be antiperiplanar to each other in E2 condition, in E2 reactions.
Yes. Next one is rearrangement reaction. The basic application of rearrangement reaction.
The rearrangement reactions are occur because of to obtain extra stability to the product or extra stable product, like thermodynamically stable product. For the formation of thermodynamically stable product, rearrangement reactions are occur. Various type of rearrangements reactions are there, like pinnacle rearrangement, bind rearrangement, different type of rearrangements reactions.
Yes. What the basic difference between elimination and substitution reaction?
Sir, substitutions reaction are just breaking of one bond. Just here the leaving group will break bond and leave, and the nucleophile will attack and form bond. But in case of elimination reaction, there are two bond breaking. So this required higher amount of energy. So we need high temperature or high thermal energy for elimination reactions. Sir. This was the first. And for substitution reaction, nucleophilicity of the nucleophile will be higher, but in case of elimination reaction, the basicity of the nucleophile will be more, then it can abstract proton more easily.
Yes. Next is Hoffman and Sergev rule. What the basic difference Hoffman and Sergev?
So according to the Sebjev rule, sir, in elimination reactions, while conducting elimination reaction, according to Sebjev rule, it says that the most substituted product was the major product. But in case of Hopman rule, the less substituted product as the major product. Hopman rules is applicable in which the substrate is more bulkier and the leaving group also more bulkier. In bulkier case, Hopman product will be the major product, or in normal case, Sedge product will be more preferable.
Yes, good. Next one, move on intermediate. What is intermediate? And what the main role of intermediate in reaction mechanism?
Intermediate are the species which form in between the reactions. It it form in between the reaction, and uh, after reaction it will also decompose based on the stability of the based on the stability of the intermediate. We can say that the reaction will go faster or slower. There are different type of intermediates like carbocation, carbanion, free radical, carbines, nitrines. These are various type of intermediates.
Yes, first is Benjan intermediate.
The benzene intermediate is a benzene ring having another extra pair of electron or bond. It
Yes.
is an electron deficient species.
The next is carbene, nitrine.
Sir, carbonyl intermediates are also two types: singlet carbene and triplet carbene. In singlet carbene, the both the electrons of carbon are lies in one orbital, but in case of triplet carbene, two electrons are lies in singlet form, not pair form, and two different orbitals. These are also electron deficient species. These are formed in between the reactions.
Yes. Next is carbocation, carboanion.
The carbocation are the positive intermediate or electron deficient intermediate. which form in between the reaction, like methyl carbocation or ethyl carbocation. These are stability of this carbocation are also different. Like tertiary carbocations are more stable than secondary than primary. Carbocation are formed generally in the intermediate of SN1 reaction. And carbanions are the negatively charged intermediate,
Yeah.
which stability is exact reverse of the carbocation. Like primary carbanion is more stable than secondary than tertiary carbanion.
Yes, good. Next is free radical. Free radical.
The free radical are the species which are generally generated by light or photochemical reactions. Photochemical reactions intermediates. These are the intermediate having just one electron in this.
Yeah, next move on other sections is organic chemistry. First, next is aromaticity. What is aromaticity?
The aromaticity describes the aromatic nature of the compounds. Aromatic compounds means which has follow Haeckel rule, 4n plus 2 pi rule, and they have the cyclic structure and they have the conjugated proper conjugations and they are the planar and they are highly stable molecules.
Yes. What the basic difference? Aromaticity, anti-aromatic, non-aromatic. What the stability order of?
Yes, sir. Aromatic compound, anti-aromatic, and non-aromatic. Aromatic compound are more stable than non-aromatic than anti-aromatic compound. Aromatic compounds are those compounds which follow 4n plus 2 pi rule, Haeckel rule, and anti-aromatic compounds are follow 4n pi rule. In both the cases, in aromatic compound and in anti-aromatic compound, there must be conjugation is there. But in case of non-aromatic compound, due to loss of planarity, they don't have conjugation, and so that their stability which decreases from the aromatic compounds.
Yes, azulene. Azulene in aromatic compound.
Yes, sir. Azulene is aromatic compound.
Can you describe what
It
the basic
follows.
application of azulene?
Sir, azulene is a compound where the 7-member ring attached with the 5-member ring. Here, the 7-member ring, while after bond breaking, the 7-member ring will get positive charge and the 5-member ring will get negative charge. And the negative cyclo pentadienyl ring is having 4n plus 2 pi electron and follow Haeckel rule, and also the um, uh, cycloheptatrine cycloheptatrine molecule also follow 4n plus 2 pi electron rule, and both are obtain the aromatic nature. So these are stable and aromatic compound.
Yes. Next is homoaromaticity. What the basic difference homoaromaticity?
So homoaromatic compound are the aromatic compound where one sp3 carbon center is there, and by loss of the planarity of this sp3 carbon atom, they can undergo conjugation and attain aromaticity. These type of compounds are called homoaromatic compound, like tropylium cation. Here also that carbon get out of the plane, and all they get in conjugation and undergo attain homoaromaticity.
Yes. Next is heterocyclic compound. What the basic application of heterocyclic compound? And how many type of heterocyclic?
So heterocyclic compounds have various type of applications, like they can be applied in medicinal chemistry.
Yes.
They were used in pharmaceuticals industry. In heterocyclic compound, the ring of the ring will form with not only carbon and hydrogen. Here, some heteroatom like oxygen, nitrogens are also there. For example, pyrrole, pyridine, furane. These type of compounds are called heterocyclic compounds.
Yes. What the electrophilic substitution rate, electrophilic nucleophilic substitution rate of this compound in heterocyclic?
Like in, for example, for pyrrole, heterocyclic ring, the nitrogen present in the cyclopentyl pentanediol ring, nitrogen donates lone pair and increase electron density on the two position and three positions. So here negative charge will increase, and it is more prone towards the electrophile. An electrophilic substitution reaction occur at uh, three positions more. And reverse for the nucleophilic substitution. For nucleophilic substitution, it is more prone for the second position.
Yes, good. Next, move on. Next one is stereochemistry. Yes, what the basic application of stereo?
So stereochemistry has first and more important application in medicinal chemistry, sir. In while preparing medicine, if we use R isomer in case of S isomer, then it will may not cure the disease or not be much effective. So it's a more crucial application in medicinal chemistry.
Yes. Yes, stereochemistry first basic is isomerase. What is isomerase?
The isomers are the compound which has same chemical formula but different structural arrangement. Isomers are various types like constitutional isomers and stereoisomers. Constitutional isomer where the connectivity of the atoms are different, but in case of stereoisomer the connectivity should be same. Like for constitutional isomer, we should consider ortho para isomers, orthogylyl, paragylyl. These are the constitutional isomer. But in case of stereoisomers, we consider this connectivity is same, but the spatial arrangement around it was different. It is above the plane or below the plane, like this.
Yes. Optically active, inactive compound in stereochemistry.
The optically active compound are those compounds which can able to rotate plane polarized light. These are called optically active compound, and those compounds which are not able to rotate the plane polarized light are called optically inactive compound. Optically active compound has chiral centers. They do not possess a plane of symmetry, center of symmetry like symmetric elements.
Yes. Next is RS nomenclature. RS, EZ.
Yes, sir. RS nomenclature are the used for generally to nomenclature of the enantiomers. Uh, like the compound which rotate the plane polarized light toward right hand side, then this is named as R isomer, and which rotate the plane polarized light towards left hand side, these are named as S isomers or S configuration or R configuration. And EZ nomenclature is generally used for the alkenes, where the priorities would be first decided. If the first priority and the first priority of the group are on the same side, then it will be named as Z isomer. If the first priority from of the left hand side and first priority of the right hand side group are in the opposite to each other, then it was named as E isomer. These are generally used for the geometrical isomer, naming of the geometrical isomers like cis trans.
Yes. DL, DL nomenclature.
The DL nomenclature are generally for the glyceraldehyde molecules. Here, the if OH group is it will named according to the OH group attached to the just carbon just above CHO group or aldehyde group. Here, if the OH group is present on the right hand side, it should be R isomer. If it is present on the left hand side, sorry, D isomer, or if it is present in the left hand side, then it is L isomer. Sorry.
Yes. Yes, cyclohexane, chair, half chair, twist boat, boat. What the stability order of?
So cyclohexane, chair conformation is the most stable conformation, then twist boat, then boat, and then half chair conformation. So
Yes, good. Next, move on pericyclic reaction. Yes, what the basic application of pericyclic? How many type?
the pericyclic reactions are various types like sigmatropic reaction, dialsald reaction. These are generally occurs under heat or in presence of light. This reaction does not involve any chemical reagent or any chemical species for to undergo reactions.
Yes, type is how many type of pericyclic? Electrocyclic, cycloaddition.
Electrocyclic, cycloaddition, sigmatropic reactions.
Yes, electrocyclic, cycloaddition, sigmatropic, and group transfer. Four
Yeah.
type of reaction.
Okay, sir. Group transfer.
And cycloaddition is two types: in and chelotropic.
Yes, sir.
Next is photochemistry. What the basic role of photochemistry?
Sir, photochemical reactions are those reactions which can occur in presence of light, sir. They require light energy to undergo reactions.
Norris type.
Photochemical reactions are various type, Norris type 1, Norris type 2.
Yes. What the basic difference? Norris type 1 and 2.
Sir, in Norris type 1, generally the bond breaking should be from alpha position. But in 2, Norris type 2, I forget little.
Yes, good.
Type.
Yeah, next is organic spectroscopy, organic part of organic spectro, infrared, UV, NMR, mass, also part of organic spectrum. Is what the basic difference?
Yes, sir. Sir, spectroscopic techniques are generally used to identify the molecules. First, in IR spectroscopy, infrared spectroscopy, generally used to know the functional group, which functional group is present in the group. It depends on the stretching frequency value. After knowing the stretching frequency, we can say that aldehyde is present or ketone or acid group is present. NMR spectroscopy, it is nuclear magnetic resonance spectroscopy. It is the it is based on the nuclear spin of the molecule. It is also used to identify the structure of the molecules. Based on the NMR spectroscopy, we can say that the environment of the we can see how what is the environment around the carbon center, what type of protons are attached to there, uh, and we can predict the connectivity of the molecules from the NMR spectroscopy after observing the ppm value obtained from NMR instrument. And from mass spectrometry, we can get idea about is the compound is forming or not by calculating the mass.
Yes, good. Yes, what the source of IR, UV, NMR?
Sir, so source of IR is um, infrared radiation. For NMR, it was microwave radiation. For mass spectroscopy, it is, for mass spectrometry, it was highly charged mm, highly charged radio wave. I think mass. I really forgot.
NMR is source is radio frequency.
Radio frequency.
Yes, IR source is near IR is nest filament. Far IR is mercury arc. And UV is ultraviolet is hydrogen deuterium.
Ultraviolet. Hydrogen deuterium lamp.
Source is tungsten filament. Basic. Yes, okay. Today, good work from your side. Next day, we will discuss in physical chemistry. Okay.
Okay, sir. I will